Hello, all of you. Today we will learn what is a random forest. In data science, it is one of the important concepts. What is random forest? Random forest is a supervised learning algorithm. It can be used for classification and regression based on ensemble learning. Ensemble learning is a type of learning where you join different types of algorithms or same algorithms multiple times to form a more powerful prediction model. Why you use ensemble learning? Ensemble learning is a type of learning where you join different types of algorithms or same algorithms multiple times to perform a more powerful prediction model. For that, we use ensemble learning. The random forest algorithm combines multiple algorithm of the same type, multiple decision trees, resulting in a forest of trees. Hence the same random forest. Hence the name random forest. Why they put random forest name only? The multiple decision trees resulting in a forest of trees. Hence the name random forest. It is also the most flexible and easy to use algorithm. A forest is comprised of trees. It is said that the more trees it has, the more robust of a forest is. And random forest creates decision trees on randomly selected data samples, gets prediction from each tree, and selects the best solution by means of voting. It also provides a pretty good indicator of the feature importance. The random forest has a variety of applications such as recommendations engines, image classifications, and feature selection. Random forest has a variety of applications. What are those? Engine, image classifications, and feature classification. It can be used to classify a loyal loan applications, identify fraudulent activity, and predict disease. Best example is credit card, bank. Example, suppose you want to go on a trip and you would like to travel to a place which you will enjoy. So what do you do to find a place that you will like? You can search online, right? Read reviews on travel blogs and portals, or you can also ask your friends. Let's assume you have decided to ask your friends and talk with them about their past travel experience to various places. You will get some recommendations from every friend, right? Now you have to make a list of those recommended places. Then you ask them to vote, right? Or select one best place for the trip. From the list of recommended places you made, the place with the highest number of votes will be your final choice for the trip, right? Suppose you have assumed that you are planning to go 5 places like Hyderabad, Mumbai, Chennai, or and Kolkata. So from 5 places, you will for some sorry 4 places. No, Hyderabad, Mumbai, Kolkata, Chennai. 4 places. From 4 places, depend on the review and depend on the recommendations, you will choose for the final decision. You will the most of the votes they have given. No, which one? For example, Kolkata they got 5 votes, and Chennai 3 votes, and Hyderabad got 6 votes, and Mumbai got 10 votes. So finally, your trip will be the based on the voting. So you will choose Mumbai is your trip. Like that, in the above this type of decisions, we used to use random forest. In the above decision process, there are two parts. First, asking your friends about their individual travel experience and getting one recommendation out of multiple places they have visited. This part is like using the decision tree algorithm, right? Decision tree algorithm. Here, each friend makes a selection of the places he or she has visited so far. The second part, after collecting all the recommendation, is the voting procedure for selecting the best place in the list of recommendations. This whole process of getting recommendation from friends and voting on them to find the best place is known as the random forest algorithm. Understand, right? Random forest algorithm. How does the algorithm work? It works in 4 steps. Select a random sample from a given data set. Select random sample from a given data set. Construct a decision tree for each sample and get a prediction result from each decision tree. Perform a vote for each predicted result. Select the prediction result with the most votes as the final prediction. Advantages. Random forest is considered as a highly accurate and robust method because of the number of decision trees participating in the process. It does not suffer from the overfitting problem. The main reason is that it takes the average of all the predictions, which cancel out the basis. The algorithm can be used in both classification and regression problems. The algorithm can be used in both classification and regression problems. The random forest can also handle missing values. What? Random forest can also be handle missing values. There are two ways to handle these: using median values to replace continuous variables and computing the proximity weighted average of missing values. And you can get the relative feature importance, which helps in selecting the most contributing features for the classifier. What are the disadvantages? Random forest is slow in generating predictions because it has multiple decision trees. Whenever it makes a prediction, all the trees in the forest have to make prediction for the same given input and then perform voting on it. This whole process is time consuming and the model is difficult to interpret compared to a decision tree where you can easily make a decision by following the path in the tree. What are the disadvantages of these two? And finding important features. What are the important features in random forest? Random forest also offer a good feature selection indicator. Scikit-learn provides an extra variable with the model, which shows the relative importance and contributions like that. It automatically computes the relevance score of each feature in the training page. Then it scales the relevance down so that the sum of all score is 1. And random forest to using Gini importance or mean decrease in impurity to calculate the importance of each feature. Random forest versus decision tree. Random forest is a set of multiple decision trees. A deep decision tree may suffer from overfitting, but random forest prevents overfitting by creating trees on random subsets. Decision trees are computationally faster. Random forest is difficult to interpret, while a decision tree is easily interpretable and can be converted to rules. Building a classifier using scikit-learn. Will build a classifier using scikit-learn. We'll be building a model on the Irish flower dataset. Irish flower dataset, it is one of the dataset in the world. which is very famous classification set. It comprises the special sepal length, sepal width, petal width, and type of flowers. There are three species or classes: Setosa, versicolor, and Virginia. We will build a model to classify the type of flower. The dataset is available in the scikit-learn library, or you can download it from the UCI machine learning repository. Start by importing the dataset library from scikit-learn and load the iris dataset with load underscore iris function. Algorithm from scikit-learn import datasets. So iris equal to datasets dot load underscore iris function. We will see the result, and you can practice it later, and I will explain you here. And print iris dot target name, and print the label species Setosa and versicolor and Virginia, and we'll get the output like Setosa and versicolor and Virginia. Sepal length centimeter, sepal width centimeter, petal length, petal width. Print the iris data top 5 records. So print iris data 0 to 5 means 0, 1, 2, 3, 4 till 4 you will print. See here, print the iris labels Setosa, versicolor, Virginia for whole data set, print 0 to 5. So you can see here, create a data frame of the iris data set of the following way. So import pandas as PD, and data equal to PD dot data frame, sepal length and sepal width, and sepal petal width. So 0 here, 1 and 2 and 3. So you just to practice it, and sepal width and you will get this result output and from the model. And first you separate the column into dependent and dependent variables or features and labels. Then you split those variables into a training and data set from the scalar dot model underscore selection. Is algorithm for training test split function, and 80% and 20% like that. And after splitting the train the model on the training set, and perform prediction on that test set. So import random forest model. So this is an algorithm you need to write like that. This is you have to, and Jupyter you can run this. You can see the output, and this is why prediction plot shape on the 30 are there. After training the check the accuracy using actual and predicted values. So accuracy is 1.0. Like that, and CL about to predict 3, 5, 4, 2, and this is you will get this one warning, and array 2 function. Hence 2 indicates the flower type Virginica, isn't it? And finding important features in this scikit-learn. There you are finding important features or selecting features in the iris dataset in scikit-learn, and you can perform this task in the following steps. First, you need to create a random forest model. Second, use the feature importance variables to see feature important scores. Third, visualize the score using the Seaborn library. This all you will get in addition to the Jupyter software, random forest classifier, and you can see here like that. Petal width, petal length, sepal length, sepal width, data type float 64. And for visualization, you can use a combination of Metaplot library and the Seaborn library. In from the it will be available in the Jupyter notebook, and because Seaborn is built on top of Metaplot library, it offers a number of customized themes and provides additional plot types. Metaplot is a superset of Seaborn. Metaplot is a superset of Seaborn, and both are equally important for good visualization, right? We have seen, and we will enter this import of Metaplot library and Seaborn library. Seaborn as SNS and Metaplot as PLT. And KX features important, and Y features and XY features. Add labels on your graphs. Plot X labels, Y labels, and plot title. For visualizations of score, see, you can find this output. Visualizing important features, petal width, petal length, sepal length, sepal width. And concentrating the model on selected features. Here you can remove the sepal width features because it has very low importance, and select the 3 remaining features. See, we have to write this here: x equal data, and petal length, petal width, sepal length. Sepal width we are removing because it is very low important. So remove features, sepal width. Y equal data, species, and we have to write the algorithm like this. From the model, you will select SCLF with random forest classifier and estimator. After splitting, you will generate the model of the selected training set features, perform predictions, unselected test set features, and compare actual and predicted values. And this is also one more algorithm you can write, and you will get this output. Here you can see. And this is what random forest and we have discussed so far. And precision is the ability of a classifier not to label an instance positive that is actually negative. Positive prediction rate, recall, is the ability of a classifier to find all positive instances sensitivity. The F1 score is a weighted harmonic mean of precisions and recall such that the best score is 1.0 and the worst is 0.0. Support is the number of actual occurrences of the classes in the specified dataset. Here you can see, and you will get the random forest resources here. Skikit-learn dot organization stable modules integrated sklearn Ansible random forest to HTML. You will get these two here so far. I hope you guys understand and like my video. Please subscribe and share to your friends so that they can learn the random, what is random forest. Random forest, it is very important concept in the data science. So please click on bell icon and please subscribe so I can put more videos, the more concept in data science. Thank you so much. Bye bye.